Hi guys. In this lecture, we are going to discuss about network hierarchies. Um, this session is more of a kind of discussion because as we go through the session, you will be able to see that there is not a kind of a thumb rule which can be which can be forced into the designs, because design is all about it depends kind of thing, because it might be what your applications, what your requirement is all about. So there might be a various ways you can design your network. So we are going to talk about network hierarchies, how and why your network should be divided into layers, and we are basically covering the 2 and 3 layer of your enterprise design or your service provider design model, where exactly you can fit your 2 layer and where you can fit your 3 layer of network hierarchy. So we begin with the 2 layer hierarchical model. um, in many networks you might need only 2 layers to fulfill all of your layer functions, which we are going to discuss about. There are various layer functions which you need to understand before you go and decide which type of layering model you should be using. So this diagram represents, this is your aggregation layer and this is your core layer. This is your 2 layer model, and in your aggregation I've this various zones. So your zones are nothing but just like your layer to domain, you can say, or you can also say like these are basically kind of different small buildings or your campus networks. So basically it's a 2 layer model, and we are going to discuss about various functionalities or your applications which you might enforce at various points on your core or aggregations or the link connecting between them. So we start with traffic forwarding. So ideally, all of your interzone traffic, that is the traffic between zone 1 or zone 2 or zone 1 and zone 3, it flows from each zone within the aggregation layers up to the hierarchy into the network core, and then to the backbone down the hierarchy into the aggregation zone. So whatever the interactions between the zone or interzone traffic, it needs to go up to your core and comes back. So because basically when you design, it will be like you'll be having a the routing inside this will be pointed towards your core, and what core decides that how the traffic needs to be forwarded to the another zone. Next thing is aggregations. Aggregation occurs maybe along the core or aggregation layer border. That means at this point you can have the aggregations that or basically your summarizations. So allowing only the interzone traffic to pass between your aggregation and your core layers. So this also provides an edge for traffic engineering services to be deployed. So you can also have a traffic engineering at this point where you're providing a summarization. So this is basically a summarization at this point. So moving ahead, routing policy. Routing policy is deployed along the edge of a core and the aggregation layer. Similar way where you have a summarization, you can have your routing policies. At these points, the links connecting core and your aggregation, you can have your routing policies enforced. You can generally, as routes are advertised from the aggregation layer into the core layer. So when you advertise the routes from your aggregation to your core, at that point you basically enforce your routing policies. User attachments. So this is your users. I just have a small square representing a desktop or a user. The user devices and servers are attached to the zones within the aggregation layer. At this layer you have a user. The separation of your end devices into the aggregation permits the separation of traffic between traffic through a link or a traffic to a link or a device. So this is a place where you can place your users. Next thing is controlling your traffic admittance. This is very important. Traffic admittance, like where you have a security gate or checking gate whenever you enter any of your hotel or your any sports ground or anywhere, any premises you enter, you have a control or you have a first barrier to check. So in a similar way in your network, when you your user or your servers are plugged on, that is the best place where you should have your traffic admittance test. So traffic admittance control always occurs where user and server devices are attached to the network, which is in your case is aggregation layer. You can also place your traffic admittance at the aggregation point exiting from the aggregation to the core. At this point where you're summarizing the network, you can have your traffic admittance, but this is not a common use because this can be done, but normally this is not the case until and unless we have a specific requirement where this needs to be done. So try to understand from this session that I am just discussing the various possibilities or various functions which you need to address before you design a two-layer or three-layer hierarchical model. So it's don't just go and listen to the session in such a way that these are the by heart kind of things which needs to be addressed and which needs to be placed at these fields. It's up to you or it's up to the requirement that where this needs to be addressed. But do remember, you need to consider these things, that it's the most important thing. So now at this point you can see that dividing the network into layers, it enables you to make each layer as a specialized and hiding information. So we move on to next section, which is more of uh, okay, yeah, I have here dividing networks into your layer, into the layer specialized, each layer and hide informations between the layers. For instance, the traffic admittance policy, which you are implemented along the edge of the aggregation layer, this point, it's entirely hiding from the network core. So what basically you are doing is core is not aware of what types of network admittance control, security policies, and all those things which you are enforcing at this particular layer. So you are hiding the information from one layer to another. This is the baseline which you need to understand why we need different layers. Like you are basically wants to hide the information from one layer to another so that layers can perform their own functionality at its best. You can also use a core aggregation layer edge to hide the informations about the topology of routing zones. For example, you can say, okay, these zones are not aware of any of the routing informations. It's just the core will summarize the information and send it to the zone. So zone will have a very limited amount of information. Similarly, each zones will summarize its own information and send it to the core. So core will have very minimal information about zone reachability. So this way you can have each zone within the aggregation layer should have minimal routing information possible, and each zone will have minimal routing informations about the core infrastructures. Both entities should have minimal interactions or minimal things to be known for your traffic or your network to be performed. This is what your two-layer hierarchy model can be. Moving on to your three-layer hierarchy, the design will have one more layer. You will be having an access layer, you'll be having a distribution layer, and you'll be having a core layer. So basically we are divided upon your aggregation to your distribution and access in terms of 2 and 3 layer. So a 3-layer hierarchy divides the same responsibility what you have in 2 layer through zones in 3 vertical networks. Let's examine the same functionalities which we have addressed for the 2 layer. For now we examine for the 3 layer. First one is traffic forwarding. In this, as with the 2-layer hierarchy, all your interzone traffic within a 3-layer hierarchy should follow up a hierarchy through the layer and back down to the hierarchy. A similar way, like your traffic which are going to pass from one zone to another, it needs to go all the way up to your distributions. From there it will get a routing and the traffic will pass to the next zone. So there in 2-layer you have a direct above your aggregation you have core. The traffic moves to the core and then goes to the zone, into zone. But here from your access the traffic needs to go to your distribution, and from your distribution it can switch to the another zone, need not to cross to the core. So you can see we are dividing the functionalities more specific to a particular layer now. Instead of core doing the same functionality in a 2-layer, in a 3-layer core is not doing that functionality of for interzone communication kind of thing. Aggregations. In 2-layer you have a single point where you can aggregate, but in 3-layer you have multiple points. It can be at the edge like this at this point, moving the at the edge of the access layer going into the distribution layer. At this point you can have your summarizations. Also at the edge of your distribution layer going into the core, you can have your summarizations. So again, as I said, there is not a thumb rule where you should do a summarization. It's just your three-layer model giving you a more flexible, or you're giving you a more applications kind of scenarios where you can have different points where you can enforce the same policies. In your two layer, you have a single way, like the traffic which is moving from your aggregation towards your core, you can do the summarizations. But here there are 2 points where you can do the summarizations. Just one point I would like to enforce here, like basically sometimes you need a dual summarizations, like you hide certain information from this place to this place, and you want to hide more information from this place to this place. So it's like the three-layer model will providing you a much zoom in kind of functionality where you can go and play with your summarization more, aggregation more in better way. So at the edge of the access layer, you aggregate the traffic in 2 places within each access zone, and following the distribution layer in the same way. Moving on ahead, you have a routing policy. The routing policy is deployed within a distribution layer in your 3-layer design. This layer will be your layer for your routing policies, and along the distribution or core edge. So distribution or core edge, here you can have routing policies. Similarly, in your 2-layer, you don't have much flexibility of providing, because this is the only place where you can have your routing policies. So in this way, your access layer is completely irrelevant for your routing policy. They do not need to take care of any of those things. You can also deploy your routing policies along the access or distribution edge, particularly route and topological summarizations, to hide information from other zones that are attached to the same distribution layer zones. You can do here, but that is more specific way or depends upon your requirement. Next functionality is user attachment. Similar way, user devices and servers are attached to the zones with your access layer. Now instead of your aggregations, you will be having an separate access layer for your user attachment. The separation of end devices into the access layer permits you the separation of traffic between traffic through a link or a traffic to a link or device. So last and the most important is controlling your traffic admittance. Similar way you are doing on the aggregation layer, because where your users are, here also traffic admittance control always occurs where your user and server devices are attached to the network, which is in this case is the access layer. You can also place the traffic admittance control as discussed previously on the aggregation points along aggregation and core edge, but similar way it's not a good practice. As you can see now, the concepts that are applied to 2 and 3-layer designs are similar, but more application points are there in the 3-layer design. So basically, if someone asks you, or if you are sitting with a customer, understanding the requirement, and you need to decide about the network of your customer should be designed in a 2-layer or a 3-layer model. So it's basically you need to understand how many different applications, these functions, I'm talking about application are these kind of functions: routing policies, user acceptance, and your summarizations, and all those things. These are kind of your functions. So you need to understand how you are going to address these functions, and do you want a separate layer to handle these kind of functions, or you can have a collapsed layer to address these kind of functions. So it's basically, there's not a thumb rule how you can determine which layer to be used in your network. As I said, how many layers to be used, it can't be a straightforward answer. The only thing is you need to examine some of the factors. We'll discuss now, so what are the factors which you should be addressed before jumping onto your solution that it should be a 2 or a 3-layer model. First is your network geography. Now you might be thinking like how your network geography can be a good feature, good factor to account like you should use a 2 or a 3. Basically, the networks that cover a small geographic space, maybe your single campus or a small number of interconnected campuses, that network you can basically go with a 2-layer model. But the networks which are spanning large geographical areas such as country, continent, or even your entire globe, there you should be basically focus on your three-layer designs instead of two-layer designs. Another thing is network topology depth. Networks with a compressed or a flat topology more bent towards using a two-layer hierarchy. For instance, your service provider network. Now you might be thinking that my service provider network is a huge network. Why I should go with a two-layer model? The reason being, your service provider network don't have a depth. It's moreover have a breadth. It's covering the entire globe, but your depth is not much. So there you should go with a two-layer model. In a similar way, because they are covering a geography areas, but reducing the number of hops through the network is critical in providing the services they sell mostly. So networks with substantial depth in the topologies, they tend to use a three-layer design where you have a more depth in your network. Another thing is network topology design. What you mean by design here is if you have a highly meshed network with many requirements for inter-zone traffic communications. Do remember, if you have meshed network where you need inter-zone communications, you should better use a two-layer model, because it's just the purpose which you want to fulfill is can be accomplished with the two-layer model. But simplifying the hierarchy to two levels tends to focus on your design elements into a meshier zone. Whereas the network that focus traffic flows on well-placed distributed resources or a centralized resources such as your data centers, where you have various remote sites connecting to your number of centralized data center. There you might need to use a three-layer design, because you are basically needs more and more functions like summarizations, your user admittance, and basically your routing policies. These needs to be properly enforced in various places. So it should better that if you have a three-layer architecture design. Last thing is policy implementation. If policies of a network tend to focus on traffic engineering, two-layer design will be good. If you more want to have a traffic engineering kind of stuffs in your network, it should be a two-layer. But networks that attempt to limit access to resource attached to the networks and other type of policies, like you want many type of policies to be enforced, that should be a three-layer design. So it's just a kind of a discussion. Again, this is not a rule of thumb that these are the things, but at least you should be aware of these things. At least when you are talking to a customer, or when you are understanding the needs or designing a greenfield network from scratch, you should be consider these factors. Okay, these are the things which might help me to design which network should be a three or which network should be a two-layer architecture. So there is not a thumb rule, do remember. And now moving ahead, very important thing is hiding layers within your layers. Um, if you are a network designer, you might have encountered this kind of scenarios where you might not handling the whole infrastructure, but you're handling a, so like for me, I'm from a service provider background, and we are basically handling a service provider network in such a way that we are providing a connectivity. So if for just a second, let me brief about you what exactly hiding layer means exactly. Suppose you can see you have an enterprise network where you have access, distribution, and co three-layer network. And imagine these are kind of like this. You have various networks, various enterprise networks, and all of these enterprise networks wants to connect to each other. That means they want some kind of enterprise backbone, which is basically being served by a service provider. So what you are doing is this three-layer hierarchical network, you are hiding behind a two-layer hierarchical network. What you'll do, you'll place two of your routers, or two of your different high-end switches, layer 3 switches, get connectivity to your to your enterprise network, attached to the routers, connect to your service provider backbone. So basically, the corporate backbone network has two layers, a core and an aggregation. Each of your aggregation layer connects to a several corporate site like this way. This will be acts like a corporate site, as I said, which might then be an individual two or a three-layer networks in themselves. So this might be a two or three, and this will be our corporate site. So it's in this network, a three-layer network is connected as a single user behind one of the aggregation layer zone. So it basically, this network is acting as a access layer or a user, not an access layer, as a user connecting to the aggregation. Large corporations commonly build their networks in this way, with the network backbone acting as a service provider to their individual networks. So you in a large enterprise networks, you might having a different um, individual networks which is connecting to the backbone. This is called hiding behind the aggregation layer of the backbone networks. Might be a two or a three layer networks. So this is what basically your hiding layers within layer information is all about. So I hope this session gives you some good overview of your layering, two-layer or three-layer hierarchical network model, and what are the basic functions and basic applications of functions which you should address when you design a three or a two-layer networks. Thank you very much.